cek 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 cek. Ya.
Okay, good afternoon, all participants. Thank you for still joining us in the second session of summer course in today. And for the second session, we will have a lecture about the DICOM hierarchy, DICOM text, and computational phantoms. And for all participants that just joined for the afternoon session and have not filled the attendance link, please fill out the attendance link that will be sent by the committee in the chat Zoom. And for the lecture session will be delivered again by Dr. Hoirul Anam. And is Dr. Hoirul Anam have ready to deliver the lecture, Doctor?
Hello, ma'am. Hello.
Yeah, inshallah.
Okay, since it is a practical session, it is okay for all participants. If you have any question during the lecture, you can just write your question in the chat Zoom, or if you have any trouble while following the lecture,
Hello.
you can also raise your hand and we will uh, get your question and Dr. Anam will answer it. Okay, without any further ado, Dr. Anam, you have 70 minutes to deliver the lecture and we will continue with discussion. But it is flexible if we have any question during the lecture. Please go ahead, Doctor.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. And now we will continue our summer course. And in this session, we will present about the DICOM info. Okay. Can you see my screen?
Yes, Doctor, it is clear.
Okay. Okay, now we will discuss about the DICOM and computational phantom. Okay, this is the table of content for this session. What is the DICOM? The DICOM hierarchy, DICOM information in IndoQCT, DICOM anonymization, phantom, and computational phantom. Okay, the current standard format for medical imaging is DICOM. For all modalities, for the CT, for the DR, for the CR, for the mammography, from the USG, all using the DICOM format. And however, for the specific purposes, other formats such as the JPEG, bitmap are sometimes still used. For example, for the information to the patient or for printing, maybe they still use the JPEG or bitmap format. But for the communication and for the storing system, the all hospital using the DICOM format. Okay, the DICOM is stand for the digital imaging communication in medicine, and this DICOM is the global standard of the communication developed under various bodies, international bodies such as the RCR, NEMA, ESC, ACC, SPR, and so on. So by using the DICOM format, the standard of every modalities and every vendors can be standardized. And in the DICOM format, we not only the image is not only contain image of the patient, but also contain the key information about the image, such as the equipment description, acquisition parameters, patient information, physician information, and so on. So many information stored in the image itself. So it is in the image and information is in one object. Okay. I think it is crucial because in the communication, if the information and the image is separated, maybe we can have the wrong information. Maybe the information from the specific patient can be used for another patient. Therefore, the information should be stored in in the image itself. So it is for the avoiding the misinformation of the patient. And the DICOM format is standardized. So in every vendors, such as Siemens, GE, although they have the different techniques, but the image should be in the standardized manner. So why the DICOM come from? In the DICOM format, it is the information about the object definition. In the DICOM information, there are information about the patient, such as the patient module, patient name, patient ID, patient sex, different physician, and so on. And also in the DICOM, there is study information, the series information, and also information. So all information stored in the DICOM with the specific standard. This is the example value for modalities. For CT, the value is CT. Description is CT. For example, for the DR, for the endoscopy, ES, and so on. So there is standard for the every modalities. This is the example of text and their attributes in CT. I think sometimes you need to understand the text and their attributes sometimes. If you want to understand more and you will get more information from the image, of course, you should understand the text and their attributes. And in today's lesson, we will discuss about this information. Okay, the DICOM format, it is very crucial in the network within the radiology department. We can see here that the imaging equipment such as CT, MR, CR, US, and so on, so many modalities and in the hospital, and they can be connected each other, and the image from the specific modalities should be stored in the cluster archive, and then we can use and analyze and use the remote, for example, physician in another location, and they obtain the image, getting the image from the archive like this. So it is important to use the standard image format. This is why the DICOM format is very important. And I already mentioned there is the hierarchy in the DICOM. From the patient information, study information, series information, and image information. And in the QCT, we show the image in that hierarchy. We can see here in the left side the DICOM hierarchy. the patient, and then study, series, and image. It means that in one patient, maybe there are many studies. And in one study, maybe there are many series, maybe with the contrast and non-contrast agent. And in the one series, I think uh, in the one series have the more images with the various slice position like this. So in the DICOM, we have the hierarchy similar to the standard one. And in the IndoQCT, we can also move from another hierarchy to another. For example, we can open the image maybe from the two patient, or maybe in one patient there are many studies. So we can move from one study to study, and we can move one slice to another slice. So we have there are many option here. This one is for moving from one slice to another, and this one is for moving from one series to another, and this one is for moving from one study to another, and this one is for moving from one patient to another. Okay, maybe we will try together using the IndoQCT. So the IndoQCT, we have the tool for moving from one patient, one study, one series, one slice to another one. And then sometimes the DICOM information is important. So in the QCT, there are many ways to show the DICOM information. I think the basic one, the information can be displayed in the short info in this position. This one is the short info of the DICOM. This is information of the patient, the ID of the patient, hospital name, hospital manufacturer, image parameters such as the tube current, tube voltage, slice thickness, field of view, and so on. And by using the IndoQCT, we can show this information as the default one, and we can also delete this information. Okay. And if you want to know more about the DICOM info, of course, you need another location to see more the information. In the DICOM, in the QCT, we can see the DICOM info more completely using this button. This button. If we click this button, so the information about the DICOM is more completely showed like this. And we can see here the tag, the description, and also the values. And I think it is important for us to learn more about the DICOM info, because sometimes we need this information. For example, if you want to make a research or another purposes, I think mastering about the DICOM information is very important for us. And then we move to the DICOM anonymization. If you are copying the patient images, for example, for the research or other purposes, it's recommended that you perform DICOM anonymization. By doing so, patient confidentiality can be maintained. So ethically we can still use the image without revealing the information about the patient. So the DICOM anonymization is very important. And sometimes if we will get the ethical clearance, sometimes the committee need the also DICOM anonymization. So it is important for the DICOM viewer have the feature to anonymize the DICOM information. IndoQCT also has this feature for the DICOM anonymization, and later we will try together how to anonymize the information from the DICOM. And now we move to the phantom and the computational phantom. IndoQCT is designed for measuring the image parameters from various phantom automatically, such as the AAPM, RCR, CAT-FAN, and vendors phantom such as the Siemens, GE, Toshiba, and so on. It is designed for automatically measure the image quality. Maybe one question arises. Can IndoQCT be used on phantoms not mentioned in the list? Of course, yes. IndoQCT can measure the image quality on the phantom, although they do not mention in the list. But if you use the phantom do not list in the list, you should measure manually. It means that you should make the ROI and locate the ROI in a specific location manually. Yeah. It is different if you use the phantom already listed in the QCT, because we already designed to automatically measure the image quality. Okay, and for the education purpose, IndoQCT can also make the computational phantom. Yeah, it is, I think, very important because by using the computational phantom, we can design with our desire. We can add the noise with the different texture. We can add the spatial resolution. We can design the size of the phantom, and so on and so on. So it is the computational phantom already developed in the QCT. And in the QCT, we can add the MTF, modulation transfer function, and we can add the NPS, already mentioned and discussed yesterday by Professor Matsubara. The MTF and NPS can be added to the computational phantom. Okay, so for the computational phantom, we can get the parameters from the measurement or by using the model, and we can also manually set the MTF or NPS. Okay, and after this, we will try together using the IndoQCT. Okay, it is important to note, if you choose the measurement, make sure that you have measured MTF and NPS before. This is the example of the model already within IndoQCT, such as the Gaussian, and then using the gamma gamma function using the Poisson-like function and so on. And this is if you use the spatial formula. This spatial formula is this is the equation, and this comes from the papers written by the Professor Bucila, published in the Physica Medica. This is the spatial phantom, and this is the formula of the spatial function. And you can also use the manual setting. You can set the NPS with the specific frequency and the specific level and so on. And this is the result, the example of the result of the computational phantom. So, as already mentioned by Professor Matsubara, the noise, even with the similar noise level, the texture will be different. And we can see the differences between the texture on the computational phantom very easily. And you can see by yourself how the difference of the noise texture if the NPS is different. Okay, this is all for me. And then we try together. And please open your IndoQCT.
So sorry, Doctor.
Okay,
Mr. Suraj
I
want to
open
share.
first the IndoQCT.
Hello. Am I audible?
Hello, Doctor.
Yeah.
Mr. Suraj want to share his problem while talking about while opening the IndoQCT. He want to share his screen.
Yeah. Maybe you can. I think you can send by the email, and maybe Mr. Aris will answer. Yeah, my email is anam@fisika at anam@fisika.fsm.undip.ac.id. Yeah.
Hello. Hello.
Yes, Mr. Suraj.
I'm audible. Actually, I load the DICOM image in my IndoQCT platform. The image is loaded, but it is not showing there. The image of the phantom which I scanned within my department.
Okay.
If it is possible, then I will share my screen.
Oh, yeah, apa. Yeah, please. So I stop.
Okay, please, Mr. Suraj.
Yeah, please. Mr. Suraj, you can share your screen.
Okay, I'm sharing my screen. This is I have installed the IndoQCT and activated also, sir.
Yeah.
And then I load, open, add DICOM user, add folder.
No.
Then
I will show you how to use that after this. Please.
no, actually, I loaded I load the image in this
Yeah.
platform.
Please wait for a minute. I will show you how to open the image.
Because image is not opening, sir, because I have the DICOM file. And the image is loaded. But it is not showing, sir, displaying the image.
Yeah. I see. No, please wait a minute.
Okay. For the problem of Mr. Suraj, Dr. Anam will answer it after this, so you can follow the lecture. Okay.
Sure, ma'am. Sure. Thank you.
Okay. Thank you.
Yeah. I see. Sometimes even the DICOM is standardized, but in fact, many manufacturers they have their own DICOM info, not standardized. So it is problem sometimes in the specific image. We already developed in the QCT to handle many problems and many differences from the DICOM information. But yeah, still many problem we face. But please send the image to me, and then we will make a investigation. What is the problem with your image?
It means
I
I
suppose
need
the
to
problem
send
is
the
the
DICOM
DICOM
image in
info,
email.
the specific DICOM info provided by the vendors.
Oh, we do have Philips scanner in our department.
Yeah, please send the image to me, and we
I need to
will
send the
investigate the problem. Yeah.
DICOM image. I need to mail you, sir. Hello,
Can you
sir.
repeat your? Can you repeat your?
Ma'am,
Yes.
shall I need to send the DICOM image in the mail to Harvey, sir?
I'm so sorry, we cannot clearly catch your voice, Mr.
Yeah. Please send your image, your sample image. Okay. Okay. We continue. Can you see my screen?
Yes, doctor, it's clear.
Yeah. Okay. Now we will open the image. You can use the sample image. For example, I use the OCR, or maybe you can use the office, the AAPM phantom images. Okay, like this. So in these images, we have only one series, from one patient, one study, one series, and in this series there are 5 images, 5 slices. Okay, like this. So because the series only one, the study is only one, the patient is only one, so you don't need this button. Because if you click this one, yeah, because the patient only one, yeah, so it is not run well. So I will use another example, maybe using the AAPM Phantom. You can see here in the AAPM Phantom, we have the 2 patients, the one patient with the 7 images, and the patient number 2 only 1 image. So in this example, we can move from one patient to another by clicking this button. So this button will move from one patient to another. If we in the patient number 1, so we can see here the study only 1, the series is only 1, and the slice is 7. So we can use this button to move to another slices like this. Okay, like this. And then this is the short information, the name, the ID, protocol, and so on. This one is the information about the institution, manufacturer, model, date, time, tube current, tube voltage, slice thickness, series number, revolution time, and so on. And you can hide, you can move the information by clicking this button A. If you click this button, the information will disappear. And OK, no, will not appear. And if you want to show again, click this button and okay, the information will appear again. Okay, this is the short information. And if you want to see the more information about the DICOM info, you can click this button beside the A. This button, the DICOM info. Click this button, so you will see the DICOM 3 view like this. There are so many information here, and it is important for us to understand this information. As I already mentioned, that the DICOM information is standardized by the many international bodies, but actually sometimes the vendors make its own DICOM info. It is the problem. Yeah, yeah, yeah. It is the common information. You can see here. It is important. You can see maybe this one is modality city. In the manufacturer, GE Medical System. Institution name is not available because we already erased this information. Referring physician name not available. Now the information this one, this one. It is important information. Second option is Excel mode. Slice thickness is in the 5 millimeters. Key VP is in the 120 kilovolt. Spacing between slices is 5 millimeters. Data collection diameter is 500 millimeters, and so on. The reconstruction diameter, so it is different between the data collection diameter and the reconstruction diameter. We can see here that the reconstruction diameter is only around a half of the data collection diameter. In this information of the distance source to detector, distance source to the patient, Kenry or detector tilt, 0 degree, table height, rotation direction, counter CW, exposure time, and so on. The type of filter is body filter, generator power, focal spot 0.7 millimeters, convolution kernel, it means that it is a filter standard, and so on and so on. So many information in the DICOM info. So maybe you need this information sometimes. So it is important for you to understand this information. And this is the DICOM information. And this DICOM information will be different from one slice to another. Especially for the slice location. I think the another information is similar, but the slice information is different. Okay, this one is the DICOM info for this slice. If we move to the another slice, this position, for example, and then we click this button, so we will have the another DICOM info. I think most information is similar, but the slice location will be different because these two images at the different location. Okay, so you can see the many information, and as already mentioned, even the DICOM is standardized, but sometimes the information is not similar. It is the problem. Sometimes in one DICOM there is a specific information, but in another DICOM there is no information. So it is the if we develop the software for many vendors, it is the problem. Yeah. Okay. Another question. Oh yeah, there is yeah. It is the limitation of the IndoQCT. We will add the search to uh, to find the DICOM review. Yeah. Thank you very much uh, for your suggestion. Yeah. Is there a way to measure the SVL values? Oh no. You can measure the half value layer. You can use the detector. Yeah, such as the maybe the RTI detector or using maybe the piranha detector. Yeah. So using the IndoQCT, you cannot measure the whole half value layer. Okay. Okay. Okay, then we move to the another topics, and now we will try to oh yeah, Mr. Suraj, I will look at your image after this. Thank you for sending your images. Okay, now we will move to the computational phantom. And computational phantom, we can choose this button. The computational phantom. Click this one. Okay, this is the computational phantom. And in this computational phantom, we have many type of phantom, such as the homogeneous phantom, point phantom, slanted edge phantom, multiple object phantom, low contrast phantom, and so on. In this example, we use the homogeneous one. And this is the metric size. The default is 512. Of course, you can change these values. The field of view is the 250 millimeters. Of course, you can also change. The physical diameter in the pixel will be of 410. It is corresponding to the 200 millimeters. And you can choose the case thickness. It is 8% from the diameter, and you can set the city number of the case and city number of the background. Okay, I will click OK and we can see together what is the appearance of the computational phantom. And this is the result of the computational phantom with the specific parameters we already use. Okay, and then I click again. You can change, for example, using this one, the case thickness, not 8, for example, we use the 15, for example, and then okay. So the case will be thicker. Okay. Okay, and maybe you can also maybe 5, and the case city number maybe 120 corresponding to the acrylic material, and the background is 0 corresponding to the water. Of course, you can also change this values. For example, you change to the 50 for example, and you can click. This is the appearance of the computational phantom. Okay, we back to the computational phantom, and then we set the background as the 0, and then we can set the spatial resolution configuration and also the noise configuration. Okay, and maybe for seeing the effect of the spatial resolution, we can use the point phantom. Can use the point phantom, the point like this. we have the point with the city number of the 2000 Huntsville unit, and it is the spatial resolution. We can use the PSF, point spread function. This is the three option, none, PSF, and MTF. If we choose the none, it means that the image is excellent without degradation in the spatial resolution. We can see without blur. Okay, we can see the result like this, like this. Okay, and then we can zoom in, for example, this one, and you can look at your mouse, and you can see here that the pixel values is around 2001. One is from the noise, yeah, because in this image we have the noise. Okay, we back to the standard appearance, and then okay, in this occasion I will set the noise the none or zero, non-zero. Okay, so these values will be exactly 2000, 3000, yeah, 3000, because there are no noise in this image. Yeah, okay. Okay, this is the image. If there is no spatial resolution added in this image, and now we will add the spatial resolution blurring, and we can use the PSF, point spread function, meaning we set in the PSF, and we can also set in the MTF, meaning in the frequency domain. We can set in the PSF in the spatial domain, and we can set in the MTF in the frequency domain. Okay, in this example, we use the MTF, and then we get the MTF. Now, if we use the MTF, we have three options using the measurement, model, and manual. Yeah, because we didn't have measurement yet, so we only use the model in this example. The model is the Gaussian. We can set here the MTF 50% and MTF 10%. In this example, for example, we set 0.5, and the MTF 50, we set 0.3, like this. And we can see the preview of the MTF of our model like this. This one. Okay, and then we close this preview, and then we okay, and then please see carefully if I press this button. So before, the image is very sharp, but if we add the blurring with the specific MTF, so the image will be worse. Okay, I click OK. This is the result, like this. The result is like this. So the spatial resolution is worse. Okay, and maybe I will set again. I open the computational phantom again, and I get the MTF. In this example, I will change the values, maybe the MTF 10 from the 0.5, and I set 0.8, for example, and the target from the 0.3 to the 0. For example, 5, And this is the preview of our model like this. Okay, I close this preview and then I click OK. Okay, and then please see carefully the image. And if I click the OK, so the image will be worse compared to the previous one. Okay, click. Oh yeah, it's better because the spatial resolution is the MTF is bigger. Okay, sorry. Okay, yeah, meaning that if the MTF is bigger, the result is better. Okay, and now I will set maybe from 0.8 to 0.3, for example, and this one is 0.5 to 0.2, for example, and this is the preview of the MTF, and I close this one and OK, like this. Okay, and then we see the image together. If I click the OK button, please look at the image carefully. Click. Yeah, we can see here that the image is blur. And in the next session, Dr. Nordiana will explain how to measure the MTF. Yeah, we can see here, it is only for the computational phantom. Okay, for the educational purposes. This is the impact of the blur on the spatial resolution. And now we will set the noise configuration. And for this purpose, I will set for the spatial resolution is none. There is no blur anymore. And then we set the noise configuration, the noise. Okay, the noise, and we can set the none, or you can set the random normal or Gaussian noise in the spatial domain, and you can also add the noise using the frequency domain in the NPS. What is the NPS and how to measure the NPS, we will discuss in another session. Okay, I click the NPS in this occasion, NKS, and then we get the NPS. Get the NPS. We have three options here. It can be from measurement, from the model, or manual one. Okay, in this example, I will show you using the model. And there are many models here: the Gaussian, flat, spatial, log normal, gamma, and Poisson-like. In this example, I will use the Poisson-like. Poisson-like, like this. The maximum values, the maximum frequency will be 1 millimeters, and then the target integral we can set here. This is the noise. In this example, we set the 5. Okay, and then I will first 5 Honsville unit, and then I click OK. You can see here that the image is sharp because there are no blur in the image, but now the image is noisy. The image is noisy with the noise around 5 Honsville unit, and we can measure. We can measure using this tool. Yeah. You can see here that the SD is around 3 Honsville unit. Yeah. Maybe if we move in another location, the noise will be different. Sometime 4, sometime 5, sometime 3, and so on. Okay. Now we back again to this computational phantom, and we get the NPS, and now we set the integral NPS. Integral NPS is basically similar to the noise level, and now I set, for example, to the 25 Honsville unit with the target with the peak frequency and mean frequency similarly. Okay, and then I click OK. Click OK. Okay, and then we will see what is the appearance of the image. Okay, and then I click OK. And this is the result. So the image is noisy, more noise in the image. Because the noise level is around 15, and we can measure the noise by using the rectangle, and we locate here in this position. You can see here that the SD, standard deviation, is around 16 Honsville unit, meaning that the noise is 16 Honsville unit. And we can also measure in another location, for example, in this location. So the noise is around 15 Honsville unit. Okay. Okay. This is the noise level. Okay. And now we will move again and back to the computational phantom, and I change the type of phantom from the point to the homogeneous one, and then I will get the NPS, and now I will change not the integral NPS, but I will change the peak frequency and the mean frequency. Okay, the model, the Poisson light is like this. This is the model of the Poisson light. The integral will be 25. F peak is 0.3, and the F min we set with the 0.27, but the model the fitting getting the values like this, 0.459, like this. This is the model of the Poisson light. The red one indicating the peak frequency, and the blue line indicating the mean frequency of the NPS. Okay. Now I will change the peak and the target frequency with the similar integral noise or noise. In this example, I changed the peak frequency from 3 to 1. Okay, and the preview like this. Yeah, the peak is the 0.1, and the mean frequency will be 0.2. Okay, like this. Okay, this is the preview, and then okay. Okay, the noise level is similar, and please see carefully what is the difference. What is the difference? Okay, I click OK. What is the difference? The noise level is similar. The noise level is similar. We can measure it's around 15 Honsville unit. You can see. Yeah, 25 ya. You can yeah, almost similar. But the texture of the image is totally different. Why? Because the frequency of the noise is different. Yeah, before the frequency is the peak frequency is around 0.3, but now the peak frequency is around 0.1. Okay, maybe we can change the parameters. Ini to 20 to 25 ya, 25. Okay, and now we will change the the peak frequency from 0.1 maybe to 0.6, yeah. And this one is maybe around 4, 5. This the preview, this one. The peak frequency is 0.6. This is the preview of the model. Okay, and then I click OK. Okay, and then please see together what is the difference. I add the noise with similar level around 25, but with the different frequency. In this model, we use the bigger frequency. This one is 0.1, and now I will try to use the frequency 0. Tadi 0. berapa tadi? 6 ya. Okay, let's see the image together. Okay, and this is the result. You can see here that the image, the noise is finer. Yeah, the granular noise is finer compared to the previous one, because in this setting we use the peak frequency larger than previous one, meaning that if the frequency is bigger, the noise frequency and the appearance, the noise is look like smaller, look like finer. In contrast, if we use the very low frequency, the granular of the noise will be bigger, like this. So it is important to underline that the noise level is not enough for characterizing the image quality. In addition to the noise level, we should also characterize the peak and the mean frequency. This is the example. The example using the computational phantom. And in the next session, we will show you how to measure the NPS from the images of the phantom. Okay, maybe you can also try with another one, another model, or with another, for example, this one is the flat. The flat meaning that there is no specific frequency. Yeah? You can try by yourself, and maybe you can also use the another model. And you can also use the manual one. This is the manual one. You can set the frequency as you want. Depend on you to set the frequency and the magnitude of the frequency. And you can also set this one, the number point and maximum frequency, and also magnitude of the noise. This is for the manual one. So it is, I think, very nice if you try and you can see the result if the parameters is already changed. Okay. Of course, if you have the measurement, you can also use the measurement. I will explain how to measure the NPS in the next session, but maybe in this occasion I will show you a little bit how to measure the NPS, yeah, by using this one, and then we use the NPS. This is the many parameters, and I will explain to you in the next session. And then maybe we using the array number maybe 9, and then calculate. This is our NPS. Our NPS from this image for measurement. This is the two-dimensional NPS. This is the ROIs for measuring the NPS. Now, because we already measured the NPS, so if we back to the computational phantom and we get the NPS, and then we choose the measurement, because we already measured, so we have this NPS from measurement, and you can also see the preview. This one. Oh, we click first. We click this one first. Click first, and then preview. Yeah, this is the NPS from the measurement. And of course, you can add this NPS to the computational phantom. Yeah, because it is the same NPS, so the result will be not different at all. But if you can measure the NPS from the images, the real images, from the example images. Okay. It is, I think, very nice, and you can doing research by using this computational phantom to see the result, to see the appearance, and so on and so on. Okay. Okay. We move to the question. The first from the Muhammad Yasin. It appears that we will need to upload our system images, after which the software will generate and display image quality parameters, such as MTF, to facilitate the evaluation of our system performance. But here we can change or play with image and changes its parameter manually. Please explain this. Yeah. How to measure the image quality, it will be discussed in the next session. Until now, we only see the and try the DICOM viewers and how to generate the computational phantom. Yeah, in the next session, we will discuss how to measure the image quality, to measure the NPS, to measure the MTF, to measure the TTF, and so on in the next session. Yeah. Oh yeah, yeah. As I already mentioned, that the IndoQCT has many functions. The first is for the image quality assessment. And the second function of the IndoQCT is for the education. The computational phantom is for education, not for the quality control in this occasion. So in the next session, we will discuss how to measure image quality image using the real image, and it can be used for the quality control measurement. Okay.
There is a comment, Professor, from Miss Mariam and also Miss Afra, that it could be a very useful way for teaching students.
From from the Afra, ya.
Yeah.
Tadi Afra.
To practically teaching student using the computational phantom.
Tadi itu ya yang dulu
In
yang
the
remove ini ya. Ya. I can remove specific information like name and the ID. Yeah. We can remove the information. Okay, I will show you how to use the DICOM animation. Okay, and now I will open the image, for example, the RCR image. This is the RCR image. The name is NA not available because we already delete this information, and we can delete or we can change the information using the DICOM anonymization. The button is this DICOM anonymization. Okay, DICOM anonymization, and in this example, you can change the patient name. For example, from NA, and I will change to, for example, Anam. And patient ID from 001, and I change, for example, to the 10. And maybe the patient birth, patient sex, maybe uh, male, for example. Is his name, maybe I change to the Diponegoro University. Address maybe Semarang. Okay, and so on and so on. And we can choose this one. We change the DICOM info not only for one slice, but for multi-slice. Yeah, okay. And then we click OK. And then we click OK. And please see carefully. And then the name, this one is NA, not available. And if I click OK, you can see here that the name is Anam. The name is Anam, and the ID is 10. Okay, and the institution now is Diponegoro University and so on. So we have already changed the DICOM information, and after this we can store, we can save our images in the specific location. So the information is already changed or already deleted. Okay. This is the method how to anonymize the DICOM information. Okay. Is there any question? Yeah.
From Miss, I think there is any question, Mr. from Miss Mariam. Even though I think it is about the appreciation. Thank you very much, Dr. Hoirul Anam. That was a very useful session. It is very important to know how to use the tools of the application IndoQCT so that we can take the best advantage of it. Well presented. Warm thanks to you. Okay, so another question from Miss Mariam. So then even if we share the document of the image for someone else to open it, they cannot see the original info, right?
No. After you anonymize the DICOM, the information is not already available in your image. The image is deleted.
Okay, it will be permanently deleted, yes?
Yeah, right.
Okay. And also, can we limit the other users from changing the info on their own? Like if we cannot give them access?
As I already mentioned, if you already change the information or already delete the information is not already available in the in your image. So if someone open your image, they cannot see the information at all because the information is already deleted. I think it's okay. Yeah. Can they edit it in the next session, for example? Yeah. If they have the software such as the IndoQCT, of course, they can already they can edit again. But the previous information is lost. The name, the institution, the physician, the ID is lost. So someone, of course, they can edit and change to another name or another institution, but the previous information is lost from the image.
Okay, doctor. Okay, that is clear. Thank you. I think it is enough from Miss Mariam Ali Said. Okay, is there any question from the participant?
Can I ask?
Yes, please.
Okay, so in this case, we modify the DICOM file either with anonymization or computational phantom, explain to save the modified DICOM file to the modified and save to the locals to be opened later.
Okay.
Maybe it can help.
Okay. I will show you. This is the I think I will open the original image in the example. Okay. The name is NA, the IT is 001. And then I will change the name by clicking this button. And the name from NA to maybe RH. And the patient ID from 0.1 and then I change to the 100. Okay, and then I multiple slice, all slices, and then okay. Okay, the name now is RH, the IT is 100. And now I save the image in the DICOM format for multi-slice. The name maybe patient A. Okay. And then I save in the specific folder, for example, and in this, I think in this position, and the E folder. Okay, and then okay. Oh, sorry. I locate in the this one. Okay, and then okay. Dah ya. Apa? Ya udah ya. Ini dah already save in the presentasi kampus. Okay. And then, for example, I open the original image and I open the another one. And now I will open the image already saved using this button. The name tadi di apa nanti? Di komputasi ya? Di apa tadi? Apa namanya tadi? Oh, this one. Patient A. 1, 2, 3, 4, 5. Okay, and then we open. Okay, we can see here. We have already opened the image, and the name is RH, and the IT is 100. So the information is modified in the image like this. So someone who open this image, they will see the name is Aris, not NA gitu. Okay, it is clear. Is it clear? Yeah, the question from the Afrah Al-Sadi, what are the available format that we can save as? Yeah, you can also save the image not in the DICOM file, but in the JPEG or the bitmap. Okay, but the IndoQCT can only open the image in the DICOM info. So if you save the image in the, for example, in the bitmap file, so you cannot longer open the image again because the IndoQCT only open the DICOM format file. Okay. But you can save the image in the another format.
Okay, doctor, there is a participant from the offline
Well,
that want to ask you a question. Is it possible?
Yes, please.
Tes.
yeah.
Oke, I want to.
Siapa?
Okay.
Yeah, please.
Is the voice have not been heard by you?
No.
Kekelum.
We didn't
Oh, boleh.
hear anything.
Oke. Quantitative methods that can be used to compare image from physical phantom or real phantom with computational phantom.
I'm sorry, I didn't get your point.
Yeah, I'm so sorry. I asked the participant to come forward.
Further, quantitative methods that can be used to compare image from physical phantom or real phantom with computational phantom. Thank you.
Yeah. Of course, you can compare. You can compare the images. For example, if you design the computational phantom and then you, for example, add the NPS, of course you can compare the result. Yeah. And using this computational phantom, it is very useful for educational purposes. For example, to see the texture, to see the appearance of the image. Yeah. But for the quality control, of course, you should only use the phantom measured from the real scanning in the hospital.
Okay, thank you, Dr. Anam.
Yeah.
Thank you so much, Doctor. There is another question from the chat Zoom from Mr. Penis Ahmed. Although you open the same image with different ID information, should not two phantom images but having different ID be appear in comparison?
Yeah, thank you very much for the very nice question. Actually, in the DICOM info, there are so many UID, unique ID. The patient having the UID, the study using UID, has the UID, the study has UID, the series also has UID. So if we see in this example, 5 series, this 5 series is each has the different UID, the series UID. Sorry, slice UID. Yes, slice UID. But they have the similar series study and patient UID. So we can see the image together. But if the image has the all with the same information, so there is a conflict, I think. Yeah, so we only can open the image with the different ID, either in the image ID or series ID or another ID. Okay. Can you understand?
I hope that will answer your question, Mr. Penis. Okay. Is there any question from the participant? Yes, there is a question from offline participant, Doctor.
Yeah, please.
Okay, thank you, Mr. Anam. My question is, if I want to make a new computational phantom with a different NPS, different TTF, can I make a different study or maybe different series? Because I don't know where the button we should use for to do it.
Yeah. If you measure if you use the computational phantom, the computational phantom automatically use the different ID, so it's no problem with that. So you can use the different parameters and you can compare, I think. Yeah, because the IndoQCT will have the different ID automatically and randomly. Yeah, so it is not conflict. Yeah. For
So it
example, you develop the computer phantom and then you save, and then you develop again and then you save again, and then you open together. It is possible because these two images, they have the different ID because in the QCT have add the ID randomly. Yeah.
okay, maybe one more question.
Yeah.
Maybe if I have a patient study with a different series, maybe a different queue of voltage or kernel, and I want to compare these two series, how I display it in IndoQCT
Yeah.
together.
It is possible. Yeah. In this example, I use this parameters from the arrays, and then I will open again. To open again, we use this the third button, this one, add DICOM, and I click this one. I images, and then I see in the C and the program file, and then in the QCT, and then program, yeah. This program, and then resources, and then RCR, and this one. I just on open. Yeah. In this example, we have the two patients. The patient number one, the name is RH, and the patient number two, the name is NA. To compare these two images, we use this button, the compare images, and then we export from this one, arrays. Okay, and this one, I open this, yeah, and and open. Sorry. Open. Okay, we have here, and this is this image is actually similar. So if we, for example, we measure the metric with the, for example, the MSE. MSE is the mean square error. because these two images is identical, so the MSE will be 0. Okay, and then we calculate, and I show the result. Okay, this and calculate. This is the result. The black image, yeah, because there are no error. There is no differences between the two images. And maybe I will change to the another slice. This one. This one is slice number 1, and this one is slice number 2. And then I compare these two images using the metric of MSE, mean square error, and then I calculate. And this is the result. This is the result. The differences between the two images in the MSE values is this one. You can see the values. Okay? Do you understand?
Okay, thank you so much, Mr. Anam.
Okay, thank you.
Okay, another question from me, Dr. Anam. In some cases, we found that the information that labeled in the DICOM info is different with the real condition in the examination. What must we do if we want to do the examination using IndoQCT, refer to the DICOM info?
I'm sorry, I can get it here.
Okay. In some cases, we found that the information that labeled in the DICOM tag or DICOM info is different with real condition in the patient examination.
How
The
it can
DICOM
be?
info,
How it can
so
be?
sorry,
How it can
Uh,
be?
such as for the TCM.
Well, TCM, yeah, TCM.
Yes.
And then?
What must we do if we face some cases such as Miss Mariam also want to know how we can how can we solve if we face the different condition between real examination with the DICOM info, or we can just change the DICOM info or what?
The DICOM info reflects the real condition. Yeah, the DICOM info contain the information about the patient, and contain information about the examination, contain information about the machine, contain information about many information. And this reflects the real condition. So the information and the image is not separated. It is in one image. So it is not separated at all. But by using the IndoQCT, we can change. It is for research purposes. For example, if we want to erase the name of the patient because of the ethical matter. So the information of the DICOM is reflect to the real condition in the patient, in the examination, and so on.
Okay. Ms. Afrah also want to know, for example, can we use the DICOM as monitoring tool?
Yeah, of course. I think so many software, they take the information from the DICOM info. For example, the information about the dose, information about the sex of the patient, information about the type of the examination, information about the diseases, and so on. So we can capture so many information from the DICOM info. It is important for the statistical analysis and so on. For example, in one hospital, they want to know the percentage between the male and female patients. So we can get this information from the DICOM info, and we can analyze this data from the DICOM. Okay.
Okay, coming back to the talking about the TCM, in some cases the info only record about the set TCM, the set
Yeah.
chip current.
Yeah.
But and you have published also the paper about the TCM DICOM also,
Yeah.
and the fluctuation affected by the TCM may be not been recorded by the DICOM. So
Yeah.
is it appropriate to us to always check first about the chip current or the parameters that included in the DICOM info, or is it just in some cases, or what is your, you can recommend it to us?
Yeah, thank you very much for the very nice question. Yeah, every image contains the DICOM info, such as the tube current and so on. So if we want to know the another tube current in the another slice, we can open the DICOM info. But by using the IndoQCT, we can extract the information in the z-axis. And I will show you. In this example, I will use the image of the patient like this. Sorry. Now, this is the image of the patient. We can see here, you can move the chat. Yeah, this one, the tube current in this slide is 30 milliampere. And the second slice, 38 milliampere. And the third slice is 44 milliampere. It means that tube current is different in every slice. And by using the IndoQCT, we can extract all the tube current by using this button. You can click here, and we can analyze the scan parameters. This is the tube current. We can also tube voltage. In this example, we only choose the tube current, and I click OK. And the IndoQCT will extract the tube current on various slice number, from slice number 1 to slice number 38, like this. Miss Diska?
Yes.
Is there any, can you get my answer?
Okay, is it clear, doctor? It is clear, and we will continue to another question from chat Zoom, doctor, from Miss Arwasani. Can you suggest a way how to use IndoQCT in master thesis? Thank you.
Yeah, I think so many titles and so many phenomena can be observed by using the IndoQCT. You can measure, for example, the MTF. You can scan. You scan the phantom in your hospital with the different, for example, the different algorithm, FPP or IR or deep learning image reconstruction, and then you get the image, and the image can be analyzed using IndoQCT. For example, the NPS, their NPS, their MTF, and so on. So by using the IndoQCT, you can do so many experiments.
Another question from Mr. Arich Naufal, doctor. Dr. Anam, have you ever find different DICOM text for the same parameter or information?
Different DICOM text for the same parameters. Yeah. It is the problem, as I already mentioned. Even the DICOM is already standardized by many international bodies, but actually sometimes the DICOM text is different. Yeah, for example, in the DICOM text for the center of location, center of rotation. Yeah, the center of rotation in the Siemens machine and the Philips machine, or in the Toshiba machine, and the DICOM tech is different. It's the problem, yeah, for us to develop the IndoQCT, because sometimes the DICOM info is different, even for the same parameters.
Okay. Another question from Miss Hajir Sulaiman Al-Siabi, doctor. Can we use this software for CAT-FAN 602 model for automatic analysis, since I think in the QCT there has not been any
Yeah,
600.
in the QCT we have many types of the cat fan, this one, but unfortunately we have no cat fan 16 and 2. And to accommodate this, you can send your images to me or to us, and then we will include your images in the QCT in the future. But if you want to measure using IndoQCT, maybe the cat fan fandom, the module sometimes similar and sometimes different. If the module is similar, you can use it. Or you can also measure using the manual one, meaning that the ROI is located manually to measure the image quality.
Okay. I think there is Miss Hajir want to ask you directly. Please, Miss Hajir, to unmute your mic and talk to Dr. Anam.
Hello again. Thank you for letting me ask the question directly. So this CAT fan 602 or 604, I think they are similar, but the only thing I found in the CAT fan manual that there is like a reference HU number, and we know that higher electron density, higher HU, but in this phantom, I don't know, is it something wrong with the phantom itself, something wrong with the manual? Because manual is saying 0.500, no, sorry, 0.500 or 0.50% is less in electron density than Derlene, or the opposite. I can't remember now, but those two materials in this particular phantom, 604 or 602, they were, I think, swapped between Bone 50 and Derlene, because the manual is saying it is higher in electron density, but the expected range is less. So I don't know, is it something that I don't understand? Because this finding, I found it and I'm just talking to myself. I have yet to discuss it to any other experienced physicist like yourself. Thank you.
Yeah, thank you very much for the question. Yeah, if the module is similar, so you can use the IndoQCT for that module. And if the module and material is different, of course, you cannot use the IndoQCT automatically using the existing type of the phantom. Yeah, the CT number of the material consists of two main parameters. The first one depend on the CT, depend on the electron density, and depend on the electron density and depend on the density of the phantom. So the electron density, and also depend on the Z effective. Yeah, so maybe they have the similar electron density, but they have the Z effective different Z effective. So the city number will be different. Or sometimes the two material have the same Z effective, but they have the electron density, different electron density. So the city number is also different. So many parameters affecting the city number.
Okay, I might send you like a photo of the manual. I found it online now. Just because I thought higher electron density, higher HU, and it's a rule. I'm not familiar with other parameters, but thank you very much for answering me.
Yeah, thank
Can
you.
I send a photo in the chat or it's not possible?
Maybe I think via email is better.
Okay, thank you.
Yeah.
Okay, thank you, Ms. Hajar, for us to Dr. Anam. And I think this is the last question for our discussion. Is there any comment from Dr. Anam to today's session?
Yeah, today's session is only for we introduce the IndoQCT and the DICOM IndoQCT as the DICOM viewer, and start from tomorrow we will explore how to measure the image quality parameters using IndoQCT. And in the tomorrow morning, Mr. Aris will explain how to connect the PAC system. It is important. Please join the next session. Thank you very much.
Okay, thank you. Thank you very much, Dr. Anam, for today's session. And I think this is the end for our lecture today. And tomorrow we will continue again with the more deeper topics about the PACS connection with IndoQCT that will be delivered by Mr. Arish Naufal, Master of Science, and also city number consistency, uniformity, homogeneity, linearity, and its measurement that will be delivered by Dr. Panji and team. And please keep please stay tuned for tomorrow's session that will be opened from 9 past 30 p.m. local time or will be begin at 10 p.m. o'clock at the local time. So oh yes, for the participant that is still having a problem, please send to at anam@fisika.fsm.undip.ac.id so we can investigate the problem that you face and we will try to accommodate it. Okay. Thank you so much for today's and see you tomorrow with the good condition and also a high participation. Thank you so much. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for all of you. See you tomorrow.